All right, questions 40 and 41. Let's read it. There are 8 singers in a competition. In how many ways can first, second, and third prizes be awarded? So this sounds like another counting principle question, which it is. There is an order to the question because it says first, second, and third prizes. That's an order to it. There are 8 singers, meaning there are 8 people that we can choose from, and each person is distinct. People or choosing people are distinct, and there are distinct roles. So, for number 40, the order matters and how the prizes are awarded. The people in the group are distinct, so they're not considered identical. So when the order matters or the people are considered distinct, we use what is called a permutation. Now, let's not confuse it with the distinguishable permutation. That's when items are distinct from each other, but in the same group, they're considered identical. No one is identical in this case. And for a permutation, the choosing are distinct items. Distinct means different from n distinct items. Is the following. The permutation of n distinct items choosing r, order matters, is n factorial divided by the quantity of n minus r factorial. And you can also use the fundamental counting principle in this case as well. So I'm going to do it 3 ways actually. I'm going to do it by using first the fundamental counting principle, then the permutation formula, then the TI-84 calculator. So way number 1, the counting principle. I want to say fundamental. So we have 3 prizes. We have a first prize, so we have first place, second place, and third place. So first, second, third. So if you win the first prize, that means you do not win the second prize or the third prize, because once you're a winner, that is it. You are selected. You are been removed. So there are 8 eligible singers for first place. 1 singer gets to first place. That means there are 7 eligible for second place. Out of the 7 that are eligible for second place, 1 is chosen. So now there are 6 eligible singers for third place. And once again, we multiply the number of outcomes for each event, and we receive 336 winning orders. Okay, that is way number 1. Now, way number 2, we're going to use the permutation formula. So I do want to say that the permutation of 8 choose 3 is 336. So I'm going to rebox that because there are 8 people and you're choosing 3, and the order matters and they're distinct. So the permutation, once again, of 8 singers choosing 3, the order matters and they're all distinct, is 8 factorial divided by the quantity of 8 minus 3 factorial. We know that 8 minus 3 is 5 factorial. So 8 factorial divided by 5 factorial. I'm going to expand 8 factorial until I can simplify. So I'm going to use a different color. 8 factorial, since I have space over here, we can write it over here, is going to equal to 8 times 7 times 6 times 5. I want to stop at 5 factorial. And the reason why I'm going to stop there at 5 factorial is because there's a 5 factorial in my denominator, and because I am multiplying in my numerator and technically in my denominator, and I am also doing the inverse operation of dividing the numerator from the denominator, I can simplify the 5s. Cancel means to make 0. When you simplify in terms of mathematics, you make that into the identity element, which is going to be 1. The identity is being 1 because we're multiplying and dividing. So what are we left with? We're left with, wait a minute, we're left with 8 times 7 times 6. So the permutation of 8, choose 3, is 8 times 7 times 6, which also equals to 336 winning orders. Hence showing the correlation between the counting techniques. And then the last way to confirm, you can just confirm it in your calculator. So type in your 8, locate PRB in your calculator, go down to the second option usually.
Lil Mabu uses this study tool.
I don't know why that came up. So we're just gonna move on to the next question. I don't have time for this. Number 41. There are 12 members on the board of directors. If they must elect a chairperson, a secretary, and a treasurer, how many different slates of candidates are possible? So for number 41, I'm going to use the fundamental counting principle since I know I can use it based on what we just did. So 41, I must choose my chair person, my secretary, and my treasurer. So that's going to be, I have 12 members eligible for chairperson. So that means 12 possibilities become chair. Once you are a chairperson, you are not going to then be the secretary as well. Each of these positions are also mutually exclusive. There's no one person that is both at the same time. So that means there are 11 people left to be the secretary, or 11 people eligible to be secretary. And then that means there are 10 people, in this case, going to be eligible to be treasurer. Also, the order does matter, and these are distinct positions because the chairperson is the leader. It is the highest position. We can multiply the number of outcomes for each event, and that equals to 1,320 possible slates. So there you go. And this also works if you use the permutation formula. No difference. All right, guys. I'll catch you in the next video. Take care.